Okay, guys, so the last 10 MCQs of this paper, May June 2009, of chemistry, AS chemistry, MCQs 31 to 40. These are the three statement MCQs, and let's get started. Alright, so 31 on a scale in which the mass of carbon 12 atom is 12 relative molecular mass of a particular sample of chlorine is 72. Which properties of the atoms in the sample are always the same? Okay, which properties are always the same? Okay, let's look at the radius. Okay, radius can change. Radius can change for different atoms, but for the same atoms, it will not change. So atoms of the same element, the radius will not change, so radius can be the answer. Nucleon number varies for isotopes. Okay, isotopes are atoms of the same element having same protons number but different nucleon number, and same goes for the isotopic mass. So isotopic mass or the nucleon number for the isotopes vary. So 2 and 3 are not the answer. 1 only is correct, and so delta is the option. Then what about question number 32? An ideal gas obeys the gas laws under all conditions of temperature and pressure. Which of the following are true for an ideal gas? These are actually the assumptions of an ideal gas that you guys need to learn in your theory part. The first one says that molecules have a negligible volume. This is true according to the uh, assumptions of an ideal gas. Intermolecular forces are negligible. This is also correct. And the molecules have an average kinetic energy which is proportional to their absolute temperature. This is also correct. So all three are correct. A is the correct option for this. Next, 33. For which reactions does the value of enthalpy change represent both a standard enthalpy change of combustion and a standard enthalpy change of formation? Okay, now first of all, for to identify, we need to know what enthalpy change of formation and enthalpy change of combustion mean. Enthalpy change of combustion is the enthalpy change by definition in which 1 mole of a compound is burned in excess supply of oxygen, and enthalpy change of formation is when 1 mole of a compound is formed from its elements. Okay, it's important that it is formed from its elements under standard conditions if we're talking about standard enthalpy change of formation. Now, first MCQ, carbon 1 mole is burned in excess oxygen to form carbon dioxide. Okay, if you look at it carefully, 1 mole of a compound of an element is being burned in excess supply of oxygen to form carbon dioxide. So 1 mole of an element is burned. So this is actually combustion of carbon. And secondly, carbon dioxide's 1 mole is formed from elements. Okay, it's formed from its elements and in their standard states. The carbon is solid at room temperature, oxygen is gas at room temperature. This is also enthalpy change of formation of carbon dioxide. So one is correct. Then secondly, it's actually incomplete combustion of carbon. So this is not complete combustion of carbon. So this is not correct. And thirdly, we form carbon dioxide's 1 mole, but it is not formed from its elements. So third is also not correct. So one only, D is the correct option. Moving on to the next MCQ 34. Okay, which statement best explains why this reaction should be classified as Bronsted-Lowry acid-base reaction? Okay, by Bronsted-Lowry definition, we know that acid is a proton donor and base is a proton acceptor. Now the ammonium ion acts as a proton donor. In this case, this ammonium ion, it donates its proton to form ammonia gas. Okay, this is correct. Now the next says that sodium chloride is a salt. Yeah, so it is a salt. That's correct. It is a salt, but it has nothing to do with Bronsted-Lowry, so two cannot be correct. One is correct, two is wrong, so three is automatically wrong. So D is the correct answer because one and three is not a possible answer option. Now going on to the next 35. The rock dolomite is a double carbonate of magnesium and calcium. Okay, when heated strongly, a product called calcined dolomite is formed, which is used to line some furnaces for the production of metals. Why is this used for this purpose? Okay, lining of furnaces is always done by refractory material, so it is actually used as a refractory material. Acidic impurities can be absorbed because this is actually a basic compound, or it is if it is carbonate, so it can react with acids and absorb them. It will reduce metal oxides to form metals. Well, actually, for this, we'll need very strong reducing agents. This is not a reducing agent, so three cannot be the answer. So one and two only are correct. 3 is not correct. Okay, metal oxides cannot be reduced by using only dolomite. Which properties in the sequence of hydrogen chloride, hydrogen bromide, and hydrogen iodide steadily increase? Okay, If you look at them, HCl, then followed by HBr, and then followed by HI, the bond length is actually increasing due to increase in the radius. Radius is increasing going down the group. Okay, so if the radius thermal stability will actually decrease according to, because the bond length is increasing, so the bond energy is decreasing, and so the thermal stability will also decrease. So if one is wrong, both of the other two are correct, because 2 and 3 is the correct option that we have. C is the correct option over here. Right, and in this case, as I told you, 1 and 2 were correct, so B was the correct option in here. Then moving on to the next part, 37. Fraction of distilled crude oil contains molecules between 15 and 19 carbon atoms. The fraction is cracked by strong heating. Why is cracking done? Okay, cracking. Why is cracking always done? Produces alkenes? Yes, it does. To produce smaller molecules with higher demand. This is the major function reason why cracking is done. To insert oxygen compounds into hydrocarbons? No, we do not do cracking to insert oxygen compounds. Cracking, by definition, is a process in which larger molecules are only broken down into smaller molecules because the smaller molecules are in a higher demand and fulfill their demand. It has nothing to do with the oxygen addition to hydrocarbons. All right, now geraniol is one of the several compounds produced by scent glands of honeybees to help them mark nectar-bearing flowers and locate the entrances to their hives. Right, this is that compound. Which reaction will it undergo? Okay, reaction with hot concentrated acidified KMnO4 to give propanone. Okay, this is a reaction from the theory part. Okay, alkenes can react with hot concentrated KMnO4 since this is a double bond. So this will break, and yeah, one is possible. Addition of halogens, yes, that's again possible because of alkenes. Okay, both the double bonds will accept the electrophilic addition reaction will occur when halogens are added to it. And then part 3 reaction with sodium hydrogen carbonate. Sodium hydrogen carbonate is a carbonate and it will only react. It is the best test for carboxylic acid. The alcohol cannot react with it. So 3 is not correct. 1 and 2 are correct. So B is the correct option for here for this one. What about 39? Okay, how can the rate of reaction between ethanol and hydrogen cyanide be increased? Okay, this is a nucleophilic addition reaction where irradiation with ultraviolet light. Actually, no. Ultraviolet light is needed for free radical substitution because the activation energy is provided by that. So if one is wrong, then second and third are correct. Then moving on to the next part, 40. A sun protection cream contains the small ester. The following ester compound as its active ingredient. Okay, we have this ester in a cream. Okay, that's correct. Then what are the products of its final partial or full hydrolysis by sodium hydroxide? All right, first of all, identify where the hydrolysis can occur. It can occur in this alkene and it can occur in the ester group. There is an ester group hidden in here. Okay, the first compound can be formed if this ester group undergoes hydrolysis. So the compound that is formed from the right hand side is going to be your first compound, because over here, since this is a double bonded with an oxygen and then the remaining CH2 and then the CH, and then this is bonded to a CH2, CH3, and then this is bonded to a CH2, 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 CH3. So these compounds will actually, this will break and they'll get an OH group on the right hand side. So one is possible. Then the second compound, it is also possible because this compound on the left hand side over here, the CH, and then the double bonded, then the CH, and then the benzene ring, and then the remaining molecule. This left-hand side is the functional group of an acid, of a carboxylic acid, and then this carboxylic acid will actually react with the sodium hydroxide that is used as an that is used in hydrolysis. So it will form the sodium salt of the acid on the left-hand side. What about the third one? The third one says it suggests that this cleavage of this bond will occur, and then this carbon will form the carbon dioxide. Carbon will form the carboxylic acid, and then that will react with NaOH. No, actually, this reaction does not happen with hydrolysis. This occurs when we react hot concentrated KMnO4 with alkenes. Only in that case we get acids, and so 3 is not possible. 1 and 2 only. B is the correct option. Alright guys, so this is for the entire paper. So the next paper's link has been given in the description. Do check that out. Thank you so much.